Good day, everyone. My task is to discuss the different terms and definitions in linear equations and the graphs of linear equations. By the way, I am Charmaine H. Flaviano. Here are our learning outcomes. After this discussion, we will be able to identify the different terms and definition in linear equation, determine the different graphs of linear equation, and appreciate the importance of linear equation. According to Israel Moore Ivor from the Great Handbook of Codes, life is a linear equation in which you can't cross multiply. If you think you can do it, you can do it. If you think you can't do it, you can't do it. It's a simple formula. So here are the following terms in linear equation. We have linear, coefficient, constant, like terms, solution, equation, graphs, variable. First, let us define linear. A linear relationship or linear association is a statistical term used to describe a straight line relationship between two variables. Linear relationship can be expressed either in graphical format or as a mathematical equation of the form y equals mx plus b. And here is an example of a linear. Next, we have coefficient. The definition of a coefficient is a number or symbol that helps to provide a mathematical result. A number or symbol multiplied with a variable or an unknown quantity in an algebraic term. So coefficient, it is a number in front of a variable or term. We have here an example from the expression 6a plus 1b plus 2x squared y. The coefficients are the following. We have 6, 1, and 2. Constant. When we say constant, as an adjective, it refers to non-variance. So as a noun, it has two different meanings. It is a fixed and well-defined number or other non-varying mathematical object. So a constant, it is a fixed value. We have here an example of a constant from the expression 5x plus 2. The constant is 2. Like terms. Like terms are the terms that contain the same letter variables which are raised to the exact same powers. So only the first number or the coefficients of the terms are different. So example, like terms are 3a and 2a. Because although they have different coefficient numbers, they have exact same letter a in them. We have here also another examples of like terms. 3d squared y, 12d squared y, negative 2d squared y, d squared y, and also bh, 4bh, negative 5bh, and negative bh. Next is solution. A solution to an equation is a number that can be plugged in for the variable to make a true number statement. So a solution to an equation, it is a value for a variable that makes an equation true. So we have here an equation 2 plus x equals 4. So the value of x is 2. So 2 plus 2 is 4, therefore 4 is equal to 4. That makes an equation true. So next we have equation. In mathematics, An equation is a statement that asserts the equality of two expressions which are connected by the equal sign. So we have here an example of an equation, x plus 5 equals 10. So there is an equal sign. Kaya tinawag siyang equation. Next is graphs. So a graph can be defined as a pictorial representation or a diagram that represents a data or values in an organized matter. So the point on the graph often represents the relationship between two or more things. So we have here an example of a graph. This one. And the last one is variables. A variable is a symbol which works as a placeholder for expression or quantities that may vary or change. It is often used to represent the argument of a function or an arbitrary element of a set. In addition to numbers, variables are commonly used to represent vectors, matrices, and functions. So a variable is a placeholder for an unknown values, and it is usually denoted by letters or symbols. So from the equation 10 equals 2x, the variable is x. So now let's proceed to the different graphs of linear equations. So we have here the following, or the forms for the equation of a line. We have the slope-intercept form, the point-slope form, standard form, intercept form, vertical and horizontal form. So let us first define what is slope-intercept form. So a slope-intercept form, the equation of a straight line in the form y equals mx plus b, where m is the slope of the line and b is its y-intercept. So we have here an example of a graph of a slope-intercept form. Next, we have point-slope form. The equation of a straight line in the form y minus y sub 1 equals m times x minus x sub 1, where m is the slope of the line and x sub 1, y sub 1 are the coordinates of a given point on the line. So example of a point-slope form graph is this one. Next, we have a standard form. The standard form of a line ax plus by equals c. The result is referred to as the standard form of the line ax plus by equals c. So we should always be able to convert from one form of an equation to another. So for example, if we are given a line in the slope-intercept form, we should be able to express it in the standard form and vice versa. Next is the intercept form. If a and b are non-zero, x and y intercepts of a line L, then its equation is of the form x over a plus y over b equals 1. And here is an example of a graph of an intercept form. Lastly, we have horizontal and vertical form. A horizontal line has an equation of the form y equals c. So it has a slope of 0. So here is the graph of horizontal form, in a horizontal form. And a vertical line has an equation of the form x equals a. So it has an an undefined slope. So here is the graph of a vertical line. So that is all about the different terms and definitions in linear equations and the different graphs in a linear equations. So linear equations are an important tool in science and many everyday applications. They allow scientists to describe relationships between two variables in the physical world, make predictions, calculate rates, and make conversions, among other things. Graphing linear equations helps make trends visible. Okay, thank you for listening. That's all for today. Thank you and God bless.